Awesome. Thank you.
Yep, we're good to go. Hello, everybody, and welcome to DevOps at Scale talk. Now, when we prepared this talk and envisioned this talk, we actually figured out that it's definitely going to be a tragedy, and it takes 3 acts to get to DevOps at Scale.
Little did we know that we will be presenting this thing in the amphitheater.
Yeah, so we almost got here in like bed sheets, but we decided not to.
Well,
because of him.
I refuse to participate.
I wanted to do that.
All right. So as we said, my name is Leonid Igolnik. I am a Vice President of Engineering with CA Technologies today. I have been doing mostly SaaS development throughout my career with companies like Taleo and Oracle, where I run engineering and operations for some of the largest software as a service products in the world. And you can find me at Ligolnik on the internet.
Yeah, and my name is Baruch, and I'm developer advocate with JFrog, the awesome company. We have a table over there. We give away those neat t-shirts, and also we have stress relieving frogs. You throw it on people that annoy you, and then your stress got relieved. We'll try it during the talk. No, we will select one of the...
All right.
We'll try that. Right, so come find us there. I am at Baruch over the internets. And I have another talk tomorrow. It's a single-track conference. You don't have any choice, so I'll see you tomorrow as well.
Now, some of us work at companies that have legal departments the size of a building, so legal makes me say that. The opinions in this talk are my own and do not represent the views of CA.
And a little bit of mine.
With that.
Okay, so let's get us started, and we start as a good Greek play with a prologue. And we are not trying to define what DevOps is, because I guess that's what all other talks try to do. So instead, we will try to guess what you think what DevOps is, and then do something completely different. So there is nothing better than Venn diagram to explain to developers, and apparently Greeks love them too. So let's do that. This is how people explain DevOps. Right? That looks familiar. So in the middle here is DevOps. And we are not going to take this approach.
Yeah. There's another set of dimensions you can look at DevOps, and it's an intersection of technology, people, and tools. And that's the lens we would like to take our perspective through the play today.
So today, during our acts, we will present those 3 dimensions and how they interact with each other while we go to scale.
Now, when we talk about scale, for us, scale is a scale. Oh, wait, I mean the continuum of scale, right? It's rarely that you start doing whatever you're doing at the top end of the performance or sophistication or complexity of any of those 3 dimensions. So you'll see today a natural progressions we've seen time after time after time, and I've seen it in the teams I have run, through the scale of DevOps emerging and maturing in the organization.
Okay, so I guess that's the introduction. And now let's look at our example company. So those guys call themselves Pentagon Inc., and they are in payments processing business. Any
resemblance
to an
company.
Existing geometrical shape company name in the payment processing is completely accidental.
Absolutely.
Yeah.
So let us begin.
All right. So first act.
Act 1, titled Fire Brigade, aka Reactive Ops. Let us set the stage.
Yeah, so this looks a little like this room, the previous slide.
Pretty much, yeah, we kind of nailed it.
Yeah, all right.
This is a bit more modern, I think.
The AV a little bit better. So let's start with describing the people of our 3 pieces dimension. And we're talking about 3 guys, very enthusiastic ones. They all come from dev background on-prem solutions, probably in the defense industry. Ancient Greek, this is what they do.
Hence
right?
the name, Pentagon.
And Pentagon, hence the name, of course. They're very smart people, really talented developers, and they're kind of hipsters a little bit. Right? So ancient Greeks, beards and everything. And so their stack is JavaScript, Node, reactive programming, microservices, hipsterish stuff. They are good.
Pretty much the cool stuff. Now let's quickly talk about the process or I guess at this stage of the company, what process? Right there.
No process. Is there a term like no ops, no process?
You know what? We should start that as a movement.
Yeah, we should coin that.
So obviously, a company of that size, 3 people, use something lightweight. They use Kanban, right? They're good engineers. They know their best practices. So they do use TDD. They use continuous integration. They have integrated and automated tests. So they started doing the right things early.
Well, talking about right things or not, they all come from development background. They follow the latest trends. So they actually know that they can get without any ops, what it's called no ops, right? And there is serverless, there is this cloud thing, and they can deploy to the cloud without ops. And that sounds like a legit decision in 2016.
For 3 guys in the garage, absolutely. And now let's talk about their tool chain.
Yeah, so this is their tool chain. They use Jira for managing their backlog and issues, GitHub, of course, for the source, and then from GitHub, Travis CI or any other cloud CI server picks up whatever they build it, and then use the Travis CI deployment target to deploy their code directly to AWS Beanstalk, and that's like a continuous delivery. Looks solid.
Looks pretty decent.
And actually works, right?
Commit, stuff goes to production.
And it actually works.
Let us begin the first act. Like any good startup, after we build the product, the wait for the first customer begins. And
so they wait.
And then, of course, we get that first customer, and what do we do then?
Drink.
And this one happened to come in on Thursday, so Friday we celebrate.
Yeah, so let's talk a little bit about the customer. They got a really big customer. One of the celebrities of the time, probably some godness or someone, actually want to process all the payments from their brand on their system. That's a huge win.
It's a perfect first customer to have on the new product.
We wish we had the one.
Yeah. So naturally, Friday rolls off, the drinking is over, and then Saturdays roll in. And then the customer calls and says, nothing works. That's a call from a customer. Well, what would be your natural reaction to that? That would be mine. And then, of course, we do this. All hands on deck, all 3 of us.
Here you go, 1, 2, 3, there are actually 4. And a boss.
And the boss, that's right, the CEO. So that's going to be easy, right? We have no ops. I've got access to Amazon. I've got root.
Yeah, that's a good thing. So we can actually take a look at the logs and understand what happens.
Wait. Where are the logs?
It's Amazon Stack. The logs are in very defined place.
Wait. We do microservices. I see like hundreds of them.
Just look for one with the exception in it.
Where is the log, though?
Find one with exception.
I see. Okay, anyhow, so I looked, and I see 3. There's like a symptom, and then there may be the root cause in this service, but this one says 3 a.m., and this one says 6 a.m.
Oh, that's because we have Amazon zones, different zones for reliability. So different services are in different zones.
Oh, okay, let me do some time zone acrobatics. Give me a second. I need to figure out, and at least there were no daylight savings on that day. It is Saturday, thank God. So Baruch, I looked at it. I tried to put the stuff on my machine. I can't recreate the build.
Well, first of all, look at the source. It looks like it was your commit on Friday evening.
I went home after that drinking thing, and I had this idea, so I committed it.
And it went to production, and now nothing works. Okay, don't worry. No blame games. No blames.
Fine.
No blames.
Let's
we're
roll
going
back.
to take the commit from Thursday evening or Friday morning, and we're just going to build it again.
So I tried, but the NPM doesn't build.
That's because NPM unpublished some module, and we cannot rebuild our software again.
And so on, and so it continues through the weekend, and through a lot of hard work, that weekend and many weekends later, they get their first customer successful.
So the real problem is we know how to firefight those events, like with hard work and dedication, all hands on deck, sleepless nights. The problem is it never ends.
And unfortunately, more often than not, the teams that just get together that have not had this experience start at this stage, right? You start with firefighting. It is what it is. Several months later, we enter Act 2 of our play, and it's called the smoke alarm installers, also known as reactive improvement. As always, let us set the stage for you.
Go ahead. Let's talk a little bit about what's new in people. And so, first of all, good news, round A, we got some money.
Money!
Yay! And that means that we can hire some developers. We're 30 now. And one of the guys actually come from an ops-related background. How many of you are from the ops-related background?
So they
you know what we're talking about, right?
Yeah.
Okay. We grow, so we have around 100 customers.
Not
Good
too
news.
bad.
Yeah, not too bad at all. And now we have a support team because it's kind of suck to get at 3 a.m. every morning on a call.
And answer like basic questions.
Yeah, no, they are like level 2, right?
Somebody else can tell them to clear their browser cache.
Yes, that's a good thing.
So as company grows, obviously the processes evolve and mature as well. In development, typically at this stage, as typical for us, we have a lot of developers. We went to Scrum. We have a more predictable delivery model. We've gotten a QA person that knows how to do exploratory testing.
Which is a fancy name for manual QA.
Okay. And of course, we've got a guy who knows that stuff, right? We've got ops now. We kind of matured past the no ops.
And this ops guy actually told us there is no such thing such as no ops, right? There is always ops, and we still want to do DevOps. And this poor guy not going to be a system administrator for us, but instead he will be a DevOps enabler for the rest of us. He will set up the tools, he will set up the processes, so all of us can do successful DevOps with the ops part in it.
And probably one of the biggest changes we make after in our processes, after being interrupted time and time again, being reactive, is we say, you know what, let's not interrupt the entire team. Let's find this poor sucker and put them on call. So we do have an on-call person now. It is important, and the role of the on-call engineer in software teams and DevOps teams is extremely important. The job of that engineer is to be interrupted so nobody does. He or she is the first line of defense against those interruptions that always come into the team, right?
Who was developer on call one time in their career? Okay, yeah, here you go.
Does anybody here works on teams that don't have developer on call yet?
Or already?
Ouch.
Okay.
So, and one last thing we did as well. Remember the time zone acrobatics we were doing, looking at the logs?
Yeah, so the obvious solution is moving to Greenwich, London. The weather is nice, and there is no problems with time zones.
No. We actually fixed the time zones. We're now in UTC, so we're good.
And the tools got evolved a little bit. We got Confluence right here as our knowledge base, because now we gathered some knowledge with all those firefighting. We know how to document what went wrong.
So when the developer on call wakes up on Friday morning, they at least know where to look. They have some things to check. They have some predefined partners. They haven't evolved yet. And I think the next talk may talk about it, to robots solving some of the problems automatically. For now, they just have the knowledge base that tells them what to click.
Yeah. Binary repositories such as JFrog Artifactory helps solve two problems. One is we have control of our dependencies, and we know exactly what's going on. It's a reproducible build. And the other, of course, we actually keep our builds. And so when we need to roll back to this previous build, we actually have it. We don't go directly to production. What else? We got much better with logs. So we bring some good log analyzer like Sumo Logic or Splunk.
Log entries, whatever the Kibana and Stash,
Kibana,
whatever your choice is.
Whatever makes sense. And now we actually know how to correlate those logs between different microservices and the time zones.
And we've also learned that it is really, really embarrassing to know about something after the customer finds out. So we put some basic monitoring in place, and we picked up Pingdom. It pings from outside of our data center to some simulated endpoint and just does a health check for us. So at least if something goes wrong, we get a call, right? That sounds like a good improvement.
So I guess everyone agrees that we are now in a much better place.
Well, let's see how the situation unfolds.
So,
as always,
let's drink. We got round A, we got bigger, we have some new stuff, really exciting times. That's a celebration time.
Except that after that Friday celebration, as you can predict, Saturday morning we get a call from a customer. This time, it's not nothing works.
Something doesn't work.
It's that thing thing in the corner that we use on occasion that is really important to our business because we're launching a big thing tomorrow doesn't work.
Maybe it's some fancy credit card from the Asian Greek National Bank, or maybe it's this NFC when you actually stack an arrow into the terminal and it should work. Something didn't work.
So, as always, now, since we have the developer on call, he's the first one who gets paged. So now not the entire team has to do that, just the developer on call. That would be the natural reaction. And then we move to fixing.
As usual, we are going to fix it.
Well, we're much better now, right? The developer on call took the first call. He looked at the knowledge base on Confluence. He has some kind of SME list because the system is large and componentized into tiny little microservices. So if he needs to escalate, he knows where to call. We aggregated the logs. So I can run a query. In my knowledge base, I typically have some basic patterns to identify certain things, maybe to trace transactions across different components.
We now can roll back easily to the build before because we have a binary repository that have all our artifacts, and we know exactly how to set up everything because those artifacts have all the needed metadata.
But unfortunately, in this case, none of those things have helped, and we start digging, and we find that we have a queue in our system, we have a queuing system, and it's overflowing, right? We're not able to take the tasks of the queue faster than we're producing them, and it has nothing to do with the code, it's just a system cannot cope with the demand. So of course we fix it, but now...
Yeah, we increase the queue size.
Or we just purge it, who cares about customer
both,
data? I don't know,
right?
I'm just...
How
purge the queue.
How important the existing messages could be, right?
Exactly, the system will self-heal,
yeah,
right?
no, it's only money, right?
Yes.
Yeah, we can lose some transactions.
So,
no big deal.
Because we now at the higher level of evolution in our process, we go to the next stage, which is analysis, right? Now we're getting much more methodical about analyzing what happened. And we obviously never do it in the middle of the weekend, firefighting the issue. But when we're calm, we typically shift to root cause resolution. And we find, in most companies of this stage, we start doing formal RCA reports. Some people call them RCA, some people call them postmortems. Depending on the organization, the terminology may differ.
And that's the time to show this little thing.
Yes, well, sure.
Our friends in VictorOps right here, they have this little book which is called On-Call Survival. And that's a coincidence, we didn't pay them to do that, but after we have this on-call engineer panicking, that's the survival book.
He goes to page 11, and it has a handy postmortem checklist right there. So if you haven't grabbed one yet, please do. They're out there on the table. But I'll show you an example on the one that my team uses today. We have obscured some of the data to protect the innocent, but here's an example of the root cause analysis report we fill. Everything, something goes bump at night.
That looks like an NSA document.
I can neither confirm nor deny the nature of the blackouts. But you can see this document consists of key things. When did the issue start? When did the issue end? How many or who was affected? How did we find out? We start with an event log, and obviously nobody's sitting there like a secretary cataloging the event log during the troubleshooting.
This queue went down. I just write it here aside for the sake of the...
Yeah, that would be awesome. Every developer loves that. No, we typically extract those from alerts, from emails, from logs, from chat logs in one of our systems, right? So we want to understand exactly what happened because it's important to know, for us at least, that the processes we have, such as an on-call SLA, a developer is supposed to answer his phone in 15 minutes. Did he? Or if the phone was dead, did the escalation kick in correctly and it escalated to the right place? Was he able to find the right SME? So we start from the events. So we have the concrete data to work on. Then we describe the symptoms, so we can use them later in both troubleshooting and maybe enhancing our knowledge base, as well as kind of making sure we all agree on the symptoms for ourselves. Then we do a more deeper analysis, and again, in some organizations, this becomes a blame game. This is not meant to be a blame game. We try to figure out what really went wrong, and in complex systems, rarely one thing goes wrong, right? Complex systems fail for when confluence event happens. I have a great example, but we probably don't have time for it right now. We'll see.
Yeah, no, the only comment on this won't happen is that it doesn't have a single name on it.
It actually doesn't. The only thing that is blocked out is the third party we integrate
Yeah, it's
with.
the name of the services, but not the developer names.
Right.
So it is not the blame game.
Then we find the root cause or the root causes, and the most important section of this RCA document for us is the next steps. Typically, the next steps are either improvements in monitoring at a minimum. In addition, this could be certain changes to the system architecture or system behavior that go into our engineering backlog.
And
right?
getting back to the Pentagon Inc., their next steps would probably be increasing the queue size, start optimizing the performance of whoever consumes those events, and of course, establishing some monitoring on those queues.
Ideally, when you have a system like that, you want to put a threshold alert for your queue, except that in our case, we kind of don't really know where to put the threshold yet. We may not have enough data, so we do our best to do a first order guess. At least if we are aggressive with our threshold, we'll get notified before things go bump at night for the customer. We can do something. We already have remediation steps documented.
So yes, that's a much better situation that we were after the first act, but still there is a lot missing there. So we make sure that the same problems won't happen again, but it actually are not very good in preventing different, or let's say in previewing on how our system is going to behave.
We've gotten really good though in making sure that things don't happen twice, right? And what I've learned was in my SaaS background that customers will forgive you the first time. As long as you can demonstrate to them that you found the root cause, you have the right set of processes and the right approaches to making sure that the same problem does not recur.
That's why those post-mortem blog posts from the system that we like so much are so important, because the companies actually show that they learned their lesson and it's not going to happen again. Something else will fail, but not that.
So, we are a very successful company. Because we're now reactively improving our systems, we're not losing existing customers, and we're very successful. We're gaining more customers.
And what can possibly go wrong? Okay, so setting the stage for Act 3, we have a lot of news. We gathered more money. Round B, yes, and now we have 100 developers, and 5 of them have the ops background, and we have a whole performance engineer in our team, in Flash. We have a chief architect. Our systems start to be complicated. It's better to have at least one guy that understands the big picture. Won't hurt. Customer success team?
Yep, so we've realized that having one engineer on call is not enough because sometimes issues come in during off hours, on hours. So at this stage, we've carved out a portion of our team. We call them customer success engineering. They are the ones that serve as the first line of defense.
So those guys are actually the engineer on call, just multiplied by experts in every subject.
And not all of them on call 24/7, 365, but their job is to make sure that they get interrupted and the rest of the development team can be protected from the interruptions. Obviously, they will reach out to the core development team if they need help, but they're that first line of defense. They, depending on the teams and depending on the companies, I've seen different setups where you rotate people in and out of that team on a monthly basis or every couple sprints. I've also seen software engineers who are highly skilled guys who just love solving puzzles, and I had a couple guys work on a team like that for me for a couple of years, and they did not want to go back to core product development. They just love solving riddles, and they were really, really good at that. Their job is rarely to fix problems. They are the triage nurse at the ER, right? They diagnose and figure out, they capture the relevant data, and unless it's an emergency, they typically put the data into the backlog.
Right. We stood it up. Now we have legal, at least a couple of guys, if not a whole building. And we have an SFO because now we have a lot of money and someone should take care of that.
Yep.
1,000 customers, good and successful startup. This is who we are now.
This is not bad, but we're growing pretty fast, so our processes are also evolving. We have multi-site development team now. So we adopted a more mature agile process called SAFe, Scaled Agile Framework. We have more formal definition of things like engineering backlog, et cetera, et cetera. We also have a new team on our staff. The team is called System Testing. They're a group of software engineers responsible to making sure that the entire system as the whole comes together and works well. While individual teams are responsible for their components, right? Somebody has to look at the system overall, provide frameworks and tooling to ensure that the end-to-end testing can still be successful. We also have an ops team.
This one is good. Now we have ops team, and all of you should go now, what? What happened to DevOps? But reminding back the first engineer with the ops background gave us, and being enabler for the rest of the company to do DevOps, now we have a whole team doing that just because we have a lot of stuff going on, we have a lot of infrastructure, we have a lot of operation aspects that someone needs to take care so the whole company can use and be successful at DevOps organization.
Our processes have also matured. For example, we stiffened our escalation paths, right? We have more formal definition of SMEs. We probably have a more senior person on call as well. So you have the developer on call. If they can't solve the problem, we have a more senior person on call. We may or may not at this stage have a system that automatically handles alerts and escalation. So people don't have to remember that we said, well, if you can't solve this problem for an hour, please call the manager, right? The system can do that for you automatically. Because our customers demand that, and we in payment processing, so we forgot one other certification here, we're now fully PCI DSS and SOC 2 compliant, which creates another need for the ops team because sometimes our customers demand that, and that creates the needed separation of concerns and separation of duties at the company. In addition to that, as I mentioned before, through the methodology of SAFe, we've gotten also better at managing the non-functional backlog. All of those root cause analysis of the problems by being reactive generate work, and that work has to be allocated effort to and has to be worked methodically. And quite often, in a lot of organizations I worked at, the chief architect takes the role of the PM or the PO for that backlog.
And the tools evolved as well from the last time we checked. Now we have configuration management. And this configuration management is exactly what the ops team taken care of by ensuring that all the platforms on all the systems and all the configurations works as expected. And we now do a proper application monitoring.
Yes, we go way beyond looking at external, let's ping a health check endpoint and see if everything is good. We can now look inside. We have a complex distributed system. We can probably trace a transaction across all the components much easier, so we can find and reduce our so-called MTTR, mean time to resolution, and find the root cause faster.
And here, the obvious names are New Relic, Ops Dynamics,
CAAPM, and
here you go,
Dynet Trace,
and many others, right? Okay, let's dive into the action of our third act.
Well, as you could have guessed,
first, we celebrate. Round B, everything is good, 1,000 customers, huge company, huge success. We are a successful startup.
And we're keeping customers. We feel pretty good about our process. Yes, things go bump at night every once in a while, but we have mastered the continuous improvement.
And then?
Well, guess what? A different fire starts. A head of development gets a call from a legal guy, and it goes something like that.
And so the legal guys apparently have their own conference. Like this one for legals. It's a nightmare, but this is what they do. And they have keynotes. And they have keynotes about, I don't know, licenses, what they can have keynotes about. And our legal comes from this conference, very enthusiastic. Guys, I heard a great talk. It was about how LGPL version 2 is dangerous. Do we use it? Do we use it?
So, as you by now used to, this is the reaction of the head of development.
Because he has no idea. So what he does?
We send the developers to look. Let's look at NPM repos, the POM files. We have an Artifactory repo, and hope for the best.
Ruby descriptors?
Oh yeah, those are always
good as well.
I love reading those.
NuGet packages descriptors, which invent their own licenses, which might or not might be LGPL2 compliant. Fun times.
Right.
But eventually we'll find it. We'll beat this report.
We'll find, we'll remediate, but that's a lot of work in those kind of things.
And then we find that some core component relies on LGPL2 third-party dependency. What do? We
remediate.
Exactly.
Costs money. Scene 2, well, this time the head of operations gets a call from a CFO because we're a big company now. We have a CFO and we need the budget for the next year. Because
so how much we are going to pay to Amazon for next year?
Well, that's the natural reaction.
That's the head of operations now because he actually has no idea.
So the best thing the head of operations can do is look at whatever metrics they have gathered so far, but in reality, at that stage of maturity, you kind of look up into the sky and say, well, maybe that much. and you hope for the best.
Yep.
Right? The next firestorm that comes the same week is also to the head of development, and the sales guys come in and say, hey, we have this customer who wants to know if it will scale. Never happens, right? Well, we have an RFP, we got to answer. Well, what do? Well, again, as you've learned
You ask your developers. Yeah, so first of all...
No, first you panic.
Yeah,
Panic
and then you ask your developers. You know, your developers go like...
No, listen, this
will
work.
be fine.
We know what we're doing. We have an elastic system. It will scale, right?
Of course we scale.
But of course you have to go and answer the RFP question. So what do? Yeah, you look into the sky and you kind of give it the best guess, right? And then the customer closes and they show up at your gate. And then you really hope for the best. And I think the last scene in this act is the head of development getting another call from sales. And this time the question is, hey, listen, can we do this in ancient Greek? Or Chinese?
Head of development goes, that?
But listen, we have a good team. We had resource bundles. We externalized everything. We know what we're doing, right?
So generally, it's kind of works.
But then you do a pseudo-language test and you realize that developers were concatenating strings and, you know, different languages have different sentence structures. Doesn't really work, so what do? You remediate again, and Google Translate to the rescue as well. Thank God it does ancient Greek.
So, guys, it's a tragedy. As in tragedy, it cannot end well. That's the end of our third act, and everything is, as you noticed, pretty bad.
So now we want to talk about the future. For any scale, there is this end at the end of the scale that you're trying to reach, and we call that end Smokey the Bear, the proactive improvement state. At CA, we've done a study as part of our application performance management product strategy research, and we've learned that about 5 to 8% of the companies that we researched managed to end that scale. So if you're not there, do not despair, but there is the path to success. And let's talk about what a proactive improvement company looks like in our mind.
And of course, the changes will be mainly in the process and in the tools.
So we'll start with the process, right? We have a performance and scalability testing, right? We're getting better at that, whether we do it synthetic testing, whether we use the live load on production environment, we split it into multiple environments, we use load splitting and simulate the testing, but we do something more proactive than reactive. We figured out how to do security and license management.
And that's back to the question that the legal department keep asking us. Now we know after each and every build which new components were added, and we can analyze whether they have license and security vulnerabilities, and actually alert very shortly after the build, but still keeping the developers free to do whatever they like.
We've gotten a bit more proactive about performance. What you typically see at this stage is more a ceremony around performance, whether it's a weekly, bi-weekly, monthly trends review, where a couple people that specialize in this field start looking at the trends and metrics that they're capturing and start getting ahead when it comes to populating the backlog with things that need to be remediated, so we don't reach that stage where the system starts melting down because the queue is overgrowing. You also see things like non-functional definition of done emerge. We have a chief architect, he has to do something. And what you typically see is blueprints, right? Blueprints for how to do those things well. This proactive improvements is not free. You have to collect an instrument. More often than not, you'll see things like standardized Docker templates emerge that have some of the instrumentation and some of the monitoring pre-baked in them. You will see standard templates for microservices. So when you start a new one, because you needed to add a functionality to the system, instrumentation and monitoring and trending comes out for free. And then in tools.
Yeah, so the tools are note that the foundations are the same. We add more and more controls and check to our system, and we can add tools like JFrog X-Ray to be on top of the licenses and the security issues that we spoke about. We add tools like BlazeMeter to continuously test the performance of our systems and be on top of that. Service virtualization.
So no system lives in a vacuum, and it is often that you have to integrate with a third party that doesn't give you a test system, so you either write your own mocks like you would for Java or any other language level unit testing. There are products out there that allow you to virtualize third party APIs, so they become your mock object, so your system integration test can run well, including all of those endpoints.
And that's the thing, right? So of course there are more, and there are different flavors of the same, but the idea is you have control, you have reproducible builds, and you have everything that you need to be able to predict how your system will perform.
And now to the last stage of this talk.
Who knows this word? That's okay. Google Translate doesn't know this word.
Yeah, we had to look it
Most
up.
of the dictionaries in the internet doesn't know that. It's actually a very fancy word to say morale of the story. Now you know, you learned something.
So if you think about this continuum, right, in the lens of tools, process, and people, the evolution along the continuum is mostly about change. And a lot of things that people talk about when it comes to introducing DevOps to their organization are all about culture change, tool change, and sometimes people change. Not everybody embraces the new world.
I think we particularly love two aspects of those aspects of change towards the DevOps that people talk to. One of them is you build it, you own it. And that goes directly to what DevOps is, right? It's a responsibility for the whole process of the software creation, deployment, and run in production.
And because my team at times tells me that I'm low on empathy, I believe pain is also very instructional. So those moments of panic in the middle of the night, I haven't found a better tool to motivate a developer to write code that is well instrumented with logs they can read in the middle of the night than having them go through that once and go for 3 hours rather than 15 minutes if they just simply added one log line.
Okay,
so
now admit you staged those calls.
Yeah.
I knew it.
Every once in a while, yeah, there's a dry run. So
that's an Israeli army training right here. It never goes away.
Practice makes perfect. So with that, we wanted to leave you with a couple books that we consider, at least I consider personally instrumental in my evolution along this continuum. Is Release It by from the Pragmatic Programmer bookshelf, and The Art of Scalability, which is a book talking mostly around the dimension we were talking about here, which is people, process, and tools as the organizations evolve to scale.
So thank you very much. I'm Baruch, J. Baruch at the Twitter, and this is Leonid, Igolnik on Twitter. Follow us, we'll continue the conversation there. We are running behind badly, but if you have any questions, we can just ignore the organizers and take them.
While the next presentation is setting up, we probably have a time for a question.
Yeah,
Maybe
so
10.
if we have like one question, we can probably let him take it while Jason gets set.
Or 5. Yeah, so I work my booth or table for Jeff Frog and Leonid just like in around. We will be there and we will see you there. Thank you very much.